Alrighty, happy Thursday. Yeah, we'll get through what we need to with object-oriented programming here. Don't worry too much about it. We've started into object-oriented programming. We're going to go a little deeper here. We might end up taking a little bit of time the following Tuesday. We'll see how far we get. That should be okay. So yeah, let me fire up PyCharm here. So we did our quick, what was that, Powerball we did as a refresher, which is a fine start for object-oriented programming as well. I'll fire up a new project. Make sure I put it in the right repository here, because reasons. I've got too many of these now. Really should spend some time cleaning these out. 2001 winter. There we go. Apparently the latest version of PyCharm doesn't have this project name. I don't know why they got rid of it. So if you don't have it, that's fine. You just add a slash here and be like, okay, I want this to be in week 2 OOP or something. And it'll make the folder for you. I don't know why they got rid of name, but sure, it's not my tool. So both ways work. And then we'll have it in our repository, in the folder, and our little main py file should be good. I don't need that one. All right, and why is that so wide? All right, so we're going to start with classes, and we'll get into inheritance, because that's the important piece here. So we briefly touched on that last time. Did we do polygons and rectangles and squares last time? Okay, good. So let's make a class for polygon. I cannot type right now, goodness. So class for polygon, and we have our init method, right? Your init's job is to give values to the attributes. So what a polygon needs to know when you make one is how many sides it has. So we'll have a number of sides value here. So you have to tell me how many sides is your polygon to make your instance a polygon. And you can have a 7-sided one, you can have a 12-sided, again, as many of these things as you want. They're polygons, right? But each one will have a unique number of sides. And then we'll also be able to set some side lengths. So I need to know, okay, side 1 is 2 centimeters, side 3 is 5 centimeters, side 4, whatever it happens to be here. So we'll have number of sides, we'll have side lengths. So those are our attributes, and each polygon will have its own unique set of those. Right? So we can have 50 of these things in memory if we want, all with its own set. So self dot number of sides is my number of sides. Now this is a little silly to keep because we can generate it if we want to. We'll see if we want to keep it or not. So, and then we want a private attribute here for my side lengths. I don't want people going and changing these things willy-nilly, right? One of the reasons we have classes is to protect the integrity of our class. So I'm going to have a function that lets you set a side length that does some sanity checking because you can't have negative lengths. Pretty sure that doesn't work. If you're a math major and you can do negative things, I don't care. We're going to say you can't have negative side lengths for a polygon because it just doesn't make any sense. Okay? So we want to make it protected so people don't have direct access to it. We'll set that up as a list then. And really we want this to be the number of sides, right? We want to have some number of sides of side lengths at this point here, right? So I can say for side in range side lengths or number of sides. I'm going to take my self.side lengths. And I'm going to append a 0. We'll say until we know otherwise, they're all 0. Right? So you have some number of sides and you have zeros for all the lengths. Great. We can go and set that. Now again, this is a little redundant to keep here because the number of sides is just the length of side lengths. Right? So you can have attributes. If they're redundant, it's not really going to hurt anything. But really, we don't want this to change after the fact. So I think I'm going to not have this one here. And then we'll add a function here for, get number of sides that just returns the length of self.side lengths here. So you can get that value, but you're not going to be able to go change it. Right? We can have get functions if you want to go get the values, which is a good practice. So here's the protected value. Here's what it is, so you can see it. And if I don't want you to change it, we won't let you change it. So at this point, we're going to say once you make a 7-sided polygon, it's always a 7-sided polygon. You can't change that sucker, right? We'll just let it stick. So there is no set if you don't want a set. Maybe we have a name, right? Should we have a name in here? Maybe we'll have, you want to call this triangle 1, large square, big trapezoid. I don't know, call them whatever you want here, right? So maybe we'll keep a name attribute here. And then we'll have self.name is the name. Now that's fine if people want to change the name of their polygon. I don't really care. We could go add, get, and set functions and make this protected, but there's probably not an invalid name for your polygon, right? So not protected because we just don't care. Right, where this one, you don't want someone changing them here. This is protected to ensure valid lengths. All right, so we've got that. So then we're going to need a set side length. Side length. That's going to need a side index. Right? Which side are you talking about here? Side number 0, because everyone starts counting at 0 like normal people, right? This is side 0, side 1, side 2 for my triangle. Just tell that to your math teacher, they'll go crazy. And then the length itself. Okay, so first we want to make sure we have a valid side index. Well, really, if you give me an invalid side index, this just doesn't work, and it will raise an exception. I don't need to do a whole lot of work already to make sure it's valid because it'll just crash on you anyway. But what I do care about is the length, right? So I want to say, hey, if the length is greater than or equal to 0, let's go do this thing. We'll say self.side lengths at the side index is equal to the length. We'll go take it. If that's not the case, right, maybe on an else I could raise a value error or do something fun with exceptions, invalid length, that sort of thing. If you wanted to get fancy, we could do that. I like using exceptions. This is the right way to do things. Please don't ever print messages in your classes because no one will ever see it and they'll just ignore it, right? If it's a bad thing, make sure they deal with it. And raising an exception means they have to deal with it or crash. Right? This forces whoever's trying to set this to a bad length to go and do something about it here. Right? We don't print messages, we go do something. Don't return values that say this was invalid because no one cares, right? They're not going to look at the return values. So either way, it should be fine here. If you're the kind of person who likes to say, I want to do this in less code, you can, if you want to be fancy. So we'll just swap this around a little bit. We'll say if it's less than 0, I'm going to raise a value error here. Otherwise, and really there is no else, because if you get to this point, function stops, right? Once you raise an exception, the function's over. So I don't need an else case here. if it's less than 0, it's bad. Otherwise, do this thing. Right? If you didn't raise an exception, this thing happens. So yeah, we eliminated one line of code. Fantastic. That's, mission accomplished, I guess. We can set a side length. So other cool things we can do with Polygon, we can have a perimeter. Perimeter? Is that an I in there? Probably is here. Should we say get perimeter maybe? Is it 2 E's, 3 E's, 4 E's? That'd be 4. No, it's perimeter, right? There's an I. Just looks weird. So we're going to return the length of, I'm sorry, not the length, the sum of self.side lengths. Right? Just sum them all up, return it. Use my perimeter. Can we get area? Do we know how to get the area of a polygon? Probably not at this point. That would be more math than we really want to do. And that gets to be complicated because it's going to be different for every number of sides. And honestly, I don't even know if they close at this point, right? Like you can give me a bunch of different lengths. I don't know if that's a closed shape or not. That's on you, I guess. That's about all we can do with Polygon, right? So we give it a name, we give it a number of sides, we can get the perimeter, we can get the number of sides. Oh, maybe a get side length here. Define get side. Now, if we want to give them all of our side lengths, we can here. We can just return that entire list, but we don't want to give them the list itself because lists are mutable. If you give them the list, they can go and change it directly, which violates the whole idea of us going and validating these things. So we're going to return self.side lengths, sliced, everything. Just make a copy, right? Slicing gives you a copy here. So this way, we're making sure we're returning copy so they can't change it, right? Sure, they can do that. Or maybe if we want, they can give them a get side length and tell me what side index. I don't know if that's super useful, but sure, get side length, given a side index, return self.side lengths at the side index. Sure, we can. Right? Whatever we think our class needs to have, we can add functions for. It's our class. All right, so we should be able to make some polygons. So we'll say, I don't know, here's a large triangle is a polygon given, we'll call this one large triangle, why not? And 3 sides. I don't know who that number is, sorry. And then we have to go set the side length. So large triangle dot set side lengths.
Why didn't you, in your initiate part, why are you appending the side length as 0? Why not the side length that you put it
I asked for the number of sides, but I don't accept a list of lengths. I could take the number of sides and the list of lengths, or just take a list of lengths. That's just an option.
So what was the purpose for the...
So this sets all of my side lengths to 0, and then I'll have all of, because remember my list to start empty, so I want to size it up to the number of sides.
Gotcha. And you're just using 0 as a placeholder. And
Yeah. Yeah, until you give it a value. 0, technically okay, I guess. There's not much of a side if the length is 0. I guess it's just a vertex then. Does that count? I don't remember math or geometry. That stuff is so long ago. We're just making up as we go. But we'll set index 0. What do we do, like a 3, 4, 5 triangle? That's pretty easy, right? So 3, 4, and 5. 1, 2, 5, and 4. How's that? So our large triangle, this should work, be a right angle triangle, right? This is our classic one here. It's nice and easy. We could do, what, 1, 1, and square root of 2, but that sounds harder. I mean, square root of 2 is kind of ambiguous. So we should be able to do that, and we can get the perimeter back out, which should be 12, right? So we print large triangle dot get perimeter, and hopefully we get 12 back out. Let's see if that worked. 12, hooray! And again, ideally we'd write some unit test code, right? Trying to do this by hand and like, oh, it should give me a 12 out is very failable, and I'm not going to run this every single time, and this gets to be really obnoxious and not very portable. So what we want to do is go write some tests. We're going to go to Polygon and say go to test, and it'll say you don't have any tests. Do you want to make new ones? Yes, please, make some new tests. Yep, and we want, now getting number of sides is really boring. Setting side length is the important one. So to test the sets, we really have to use the gets, so we're not going to test the gets separately, right? We can set side lengths and then get the perimeter, and we know it worked if the perimeter works. Maybe it's a little bit cheating, but we're going to try and be efficiently lazy here and take care of, so really one test will do it all. Right? Should be able to do all of them here. So we got a new file that imports from unit test, our test case function. And we don't want to fail, right? So we're going to test our get perimeter. So we're going to arrange, we're going to act, we're going to assert. We did this last time, right? Okay, good. I was scared we didn't get to this yet. So what do we need here? So we need the expected perimeter, or expected side lengths, I guess, right? So expected side length 0, we'll say 3, and we'll just copy paste because that's boring here. 1, 2, 4, and 5. Can we put these in a list? I don't know if that makes it any easier or not. It's still going to be a lot of, similar amount of code here. And then an expected perimeter, meter, is going to be 12. All right, so we've got all the things we want to do here, and then we're going to make the triangle. Right, so then I'll have my triangle equals a polygon given. We don't really care about the name. I guess it doesn't. We can test the name as well. Sure, why not? So an expected name is triangle. So we'll give it the expected name, and we'll give it 3 for number of sides. I guess we can test that one too. Now I'm feeling bad here. Expected number of sides. Sides is 3. Right. We should probably test all of the get functions here because I said we should. Cool. Now we're going to act. Right? So the code we're actually testing, well, I guess we can go and set, right? We're not testing the sets at this point, we're testing perimeter. So I'll take triangle.set side length of 0 to side length 0, and side length 1 and 2 to length 1 and 2. Oops. 1 and 2. All right, now we're going to act. So all the code we want to test here. So now we'll have an actual side length 1. 1 is triangle.get side length of 0. Oh goodness, no. I should have named, 0. There we go. I did start with zeros. 0, 1, and 2. 1 and 2. An actual name is triangle.getName. Oh, we just have name. I guess we don't even need to test that then, right? Because that's not even a function? Okay, forget that. We don't care about the name. Name can go away. So I want to do more things we need here. So we don't need name. We'll have an actual perimeter. It's triangle.getPerimeter. Okay, so we're getting the individual lengths. We're getting the perimeter. Cool, and then we're going to assert. Did we get what we expected? So assert equal. my expected side length 0, and my actual side length 0. And again, we copy paste a bunch. We change a couple things. It's really tedious to put these together, I promise, but it's worth it. 2, 1, and then my perimeter and the actual, actual perimeter. All right, is that all of them? So now we're going to test, did it do what we expected it to do? Oh, the number of sides, right? Actual number of sides. If we wrote the code, we might as well test it, right? Because if we're not going to test it, just get rid of the code. Is triangle get number of sides here, and one more assert equal for an expected number of sides and an actual number of sides. Okay, and let's run it. See if that one runs for us. We should get a passed. Yay. Now we feel good about ourselves, right? Now we can get that garbage out of here because we don't need to be testing it in this code, right? Because it'd be nice if this was a module. So we can even rename this one here, right? So let's go rename to, I don't know, Polygon. Sure. So here's a Polygon module now, and we're going to test the Polygon module in our test code over here, right? So we don't actually have any runnable code. We just have here, if someone else wants this module, they can go and use my module, which is the ultimate dream of object-oriented programming, is stuff is reusable and portable. The code was so good and amazing, everyone's going to want to use my Polygon code. We know that's a bunch of garbage, but again, we're going to practice. Eventually, we'll get to some interesting modules we may or may not want to keep. Maybe. But that's what we do all the time now. There are modules out there you can import that everybody uses because they're amazing and fantastic and people support them. So that is the dream, and it does happen. But again, for our stuff in schools, no, that's okay. But we're going to practice it anyway. All right. Next with Polygon, I want to practice some inheritance, right? So we are a Polygon. I can make another module if I wanted, which is fun. I like modules, so let's make more modules. So let's go add a new Python file. We'll call this one, how about rectangle? All right, so we're going to say we want to import Polygon. Lowercase Polygon. There we go. And if you want to save a little bit of typing, right, we want to say from Polygon, import the capital P Polygon class. That way we don't have to say polygon.polygon. Putting one class per module is a little silly. I really like it because it makes me happy, and then my Git history looks really clean. Not everybody agrees with me, and that's okay. Not everybody does it. That's fine. So I will have one module per class because it entertains me and makes me happy. So from here then, I'm going to make a rectangle class. We're going to have class for rectangle, and the rectangle will inherit from Polygon. So if you want to have inheritance, we give a set of parentheses and say, this is the class we inherit from. So at this point, a rectangle is a polygon. Creates an is a relationship. So it does all of the things Polygon does. Now, what makes rectangle special? Right? Inheritance lets us add functionality, add things that are special, or change behaviors of our parent that we don't want. So what makes rectangle special? Well, we have 4 sides. That's kind of boring here, but that's okay. So for my init here, I probably still want name. But you don't have to tell a rectangle it has 4 sides. That'd be pretty silly, right? And again, we want code to be nice and easy to use here. So for our init function, and it's even warning us here, call to init of superclass is missed. If your parent class, your superclass, your base class, right, because we have so many terms for these things, I don't know why, has init with parameters, you have to call it. There's no argument init. The only way you can create an instance of it is by calling that function. Because when we create rectangle, it also calls the init for polygon because it is a polygon. And all of those attributes have to be set for polygon so that they exist for rectangle. So it's saying, okay, it doesn't have it. So let's add the call, right? And again, we don't need the number of sides because that's silly here. We can just say, hey, I want to call my superclass init function here. Pass it the name that you just gave me. And then, by the way, my number of sides is 4. I have 4 sides. Life is good as a rectangle. Okay? Other things we need to do here now, though, are change a little bit of behavior. If you can go and set a side length of a rectangle, you might make me not a rectangle anymore, right? Because rectangles mean that my lengths match and my widths match, right? They have to. So what we're going to do is override this behavior. So we can add this cool @override tag here so that Python will go and make sure, or PyCharm will go and make sure that I'm actually doing it. So we're just saying, hey, I'm trying to override it here. Tell me if I did something stupid. Which happens all the time, and that's okay. That's why we have these tools and these little tags here. It's an annotation. So we're going to say this is my defined set side length, and it knows, oh, hey, here's the function here, side length, side index, and length here. Fantastic. So with the override, we want to change the behavior. We want to do something different than we were doing before. So to do something different, then I'm going to say, hey, if my side index is, how about mod 2? So remember, this is just shortcut here because Python is truthy. This is a shortcut for odd, right? If modulus 2 is true, that means it's not 0. Oh, I'm sorry, not odd, for not 0. So it's 1 or 3. I guess technically odd, right? So the modulus is not 0. If you're side 0 or side 2, for the sides, that'd be false, because 0 is false. 1 or 3 is going to be true. So I'm just trying to save a little bit of typing here. So we'll call these the odd ones. So if you gave me something that wasn't 0 or 2, I'm going to go and set both 1 and 3. So you probably gave me 1 or 3, right? You could have any sort of different ifs here if you wanted here. I like this one because it's a silly little shortcut, and we get to practice Python being truthy. So we want to say then, I will need to change my side lengths for 1 and 3. So to do that, I have to call my superclass dot set side length of 1, given the length, and I'm going to call the superclass set side length of side index 3. So let's go set them both. I don't care which one you did, I'm going to go do both to make sure that my lengths stay the same and my widths stay the same. Right? And then my else case here is the exact same thing, but now I'm going to do my 0 and 2. So if it was false, then it was either you already told me 0 or 2, or something invalid we didn't have, and I'll just go set 0 or 2. Right? Again, I don't need to check the lengths to make sure they're valid because it's already happening in my superclass. We don't need to do more work than we need to. It'll crash then. We'll raise an exception. Just make sure that we're keeping length the same and width the same. Right? So we're overriding, we're changing the behavior so something different happens when you call set side length. And now we can add some new functionality. What other cool things we can do as a rectangle is we can get the area. I know how to get the area of a rectangle. That's my self dot get side length of 0 times my self dot get side length of 1. Oops, get side length. Side length of 1. Right? Length times width. I can get the area. I can already do perimeter because Polygon can do perimeter. I don't have to reinvent that myself here. Now, I could add a get length and get width if I wanted to make rectangle a little easier to use. Totally optional, but we can get length. So return self dot get side length. I don't know, are lengths the evens and widths are the odds? I don't really, it's okay. How about we call it that? And then if we wanted to, we could even add get set length and set widths to make life easy, right? We want classes to be easy to use here, so we'll have a set length given the length, and all we're going to do is call self.setSideLength of 0 to length, because those are the evens. That'll set both for me. I don't want to have to type the same code twice here, right? Because having the same line of code more than once means you should feel bad about yourself. It's a pretty good rule of thumb, right? We want to avoid that. So we can set the length, we can get the length, and then how about set width and get width? I don't know if that might be too much trouble, but it's okay. This is set width here. And sure, we might as well call it width. It doesn't really matter what we call it. So of 1 and width. So now I can set the length and set the width more easily in my code here. And how do we know it works? I'm glad you asked. We should test it, right? So let's go add some tests. So let's go to test. They don't exist. Let's make some new tests. Sure, I want to test my probably get area. I can test the other things while I'm doing it, as we go here. We should probably rename this one here to test polygon, just to be nice here. It's nice when things match by convention. So test polygon, and this is the test rectangle class, right? So you can test polygons, you can test rectangles, and we'll do more as we go. So we're going to arrange, we're going to act, and we're going to assert. So we'll have an expected length is, 5, and expected width is 4, and expected area is 20. Oops, equal sign, there we go. And maybe we want to check perimeter. Really, we don't need to test perimeter because we already tested it, right? It is a polygon. There's already code that tests polygon. You don't need to do more work, right? It's already been tested. Rectangle can do it, but it's not part of the rectangle class, right? It's part of this parent class. We don't need to go test it again. Just test we can do the things we're supposed to do, right? And let's make a rectangle then. So rectangle equals a rectangle. What name is this one here? Again, the name doesn't matter. We'll just throw it away. So I'll just put a blank in here. And then we'll have an actual, we need to go set, right? So rectangle dot set length to expected length, and then we'll set width to the expected width here. And then we'll have some actual lengths and widths. Length is my rectangle dot get length, and an actual width is my rectangle dot get width. And then the actual area, my rectangle dot get area. Awesome. And we can go to assert. Self dot equals, assert equal, my expected area, and the actual area. And sure, we'll copy, paste, and change. My expected width, and the actual width, and the expected area length, right, with the actual length. Hey, and we'll give that a run. See if that one passes. Hey, that one passes. Nice, we feel pretty good here. All right, so we did rectangle, right? So, yeah.
I have a question. What are you testing on the rectangle? Are you testing the formula?
I'm making sure that the code I wrote does what I expect it to do.
Or what is it expected to do?
Calculate the area. And to be able to set lengths and widths with a set length and set width function, which calls set side length, is just overridden, which calls the other set side. Like, it's this whole chain of things that's happening, but I want to make sure all the code I wrote works.
Okay.
Yep. Yeah, so the new stuff was area and length and width. So we're testing the new stuff.
When you call an inherited class, it's just like you would just put rectangle dot whatever function, right? You don't have to mention anything about polygons.
Nope.
So automatically.
No, so if we wanted to add like a main file here, you could go from rectangle, import rectangle. Oh my goodness, wow. Import rectangle. So we can make a new rectangle, right? So here's, a rectangle. It's a rectangle of some rectangle. Wow. I'm trying to type too fast, I'm sorry. Dot set width, 4, and rectangle dot set length 5, and we don't even have to mention polygon.
Yeah.
So it works because the import essentially like copy pastes. So by importing rectangle, it also then imports polygon. From typing import override. What the heck? Oh yeah, okay. That's for my annotation. I didn't recognize that one. Yeah, it'll essentially copy paste the polygon in for me, so we don't have to do that separate. If we want to have that shortcut for naming polygon, I have to say, from polygon, import polygon. But at this point, I can say polygon dot polygon because it's imported it indirectly, right? So modules will kind of follow that chain. It gets to be a little messy, so you want to be a little careful too. Like importing someone else's module, if it imports a bunch of modules, it's imported a bunch of stuff. You don't really necessarily know what it all imported. That's how you get those really fun dependencies. So like when you import one thing, we go to our import matplotlib, matplotlib.py plot py, something like that. Isn't that what we usually do? Or plt. Thank you, plt. When we go install this, and we go look at what's all installed, we have now a bunch of modules here. Right, we go to our, this one here, our project interpreter. Oh, it's still installing. We can see it in a second. Maybe we will. This was very exciting. It's good to take a second. I've been talking fast. I feel like I've got a lot to get through. I've had a lot of coffee today because I'm really tired. There it goes. All right. Did it install? Installed. Okay, now let's go take a look at our settings. Here's all the other stuff that happened just by installing matplotlib. Right, so all these other modules got installed that it's importing. So I can do a bunch of things now. I don't know why we need font tools, but sure, we have font tools now. Probably for some of the output to make the legends look pretty or something. It's like, I don't know. I don't know what a lot of these are. Doesn't matter too much, right? So why did we go down that rabbit hole? Can we import without saying Yep, I remember now. Sure. You okay so far? All right, so next then, we can make a specialized version of rectangle, right? We can go as many rabbit holes as we want. You can inherit and inherit and inherit and inherit and inherit as much as you want to here. Python doesn't care. Let's make a new module. Let's call this one square. So square then, we're going to say from rectangle, import rectangle, right? All squares are rectangles. So my class square then inherits from rectangle. So what do we want to do different? Well, you can't set width separately in a square. It's really the only thing that's different, but we still need an init method, right? Because we accept a name. So we need a name, right? And yes, it's going to warn us, and this is my favorite way because it adds the code for us here. Just tell your superclass, here's your name. Great, we don't need number sides or anything here. So the only thing we want to do then is we want to override my set length here. And I want to override set width. At override define set width. Right? I'm going to change those, and all I want to do is call both. Right? So I'll say, hey, superclass dot set length of the length, and then hey, superclass set the width of the length. And if you call set width, then all I need to do is call self.setLength, given the width. And I don't even need to call superclass twice because I've already done it. Look at that, I saved one line of code and don't feel bad about myself. Right? So I'm changing the behavior of the sets here because they all have to be the same. This is not the greatest example of inheritance and being fun with code, but, you know, sure. Now we've changed the behavior because that makes us a special type here. Can't really do anything else special. You covered it all in rectangle, but now you can make something that is a square and will stay a square no matter what functions you call, right? Which should work out relatively well for us, I think, here. I think we want one more time then, one more override for set side length as well. So given a side index, let's just call self.setLength of length and self.set length of the length. So one more override just in case, because the rectangle version was going to set them separately, right? We want to make sure we're covering all of our cases here. I think that ought to work for us here. I'm not even going to bother testing this. There's not really anything here. We could test that they all get set the same. That seems really boring. And just making one and calling one set, like we can make a set length. It's kind of silly at this point. Are we okay so far? Now the next thing we can do is make another class, right? Another module. Why not? Let's call this one triangle. Right? Are triangles polygons? Yeah, triangles are polygons. So we're going to say from polygon, import polygon. Right? Back to the base polygon here again. So we're going to define triangle. Triangle is a type of polygon. So with triangle here, right, our init method. Oh, goodness gracious. Init, yes, init, thank you. It has a name. Name. Now, we know how many sides triangle has, so sure, let's go add this one in. Superclass call. We don't need the number of sides because triangles have 3 sides here. I can set them independently, however I want here. So what's different about triangle is I might be able to do a get area. Now, get area is fun. I always thought you had to know the base and the height, but it turns out there's a formula for it. You guys know that?
It's half base times height. Is it a triangle?
Yeah, but if you don't know what the height is, if we only have side lengths, you can figure out the area of a triangle. Trigonometry is neat stuff here. And I have to look it up every time. So area, a triangle from side lengths here. This one here. Where's like the formula? Give me the formula. 3 side. Are any of these any good? Oh my goodness.
Can you like finding the sine and cosine?
No, so we don't even have to do that. There's a.
You just need the area?
Yeah. I'm trying to find.
1/2 base times height.
But we don't have the height.
He's saying if we don't have the height,
Yeah.
what would we?
How to find? It's this one. Is it this one here? This one. This is what we're looking for. The square root of s times s minus a times s minus b times s minus c, where the semi-perimeter is half the perimeter. I never knew you could do it.
Yeah, that's the first time I see that too.
Yeah, forget the height. We can use a semi-perimeter, right? I don't know. Sure. So let's do it. So we need the square root of the semi-perimeter times the semi-perimeter minus the semi-perimeter. Sure. So we need the semi-perimeter. Perimeter is self.getPerimeter divided by 2. That's our semi-perimeter. And we can return. Now we need the square root, right? So it's we want to import math. Import math. Math.square root of the semi-perimeter times, then in parentheses, right? We got to force order operations, minus self.get side length, get side length of 0. Oh goodness, this is going to be a little bit long, isn't it here? Times that. Can we back that up a little bit? There's that one. Times. No, I said not that one. There we go. The semi-perimeter minus 1 times the semi-perimeter times 2. Why is that so weird with the formatting here? What happened here? Okay, all of that. One more parenthesis here for the math square root. Is that the formula?
Yeah.
All right. Awesome. Let's see if it works. So let's go test it. Go to test. Create a new test for get area. Sure, let's test get area. So we're going to arrange. We're going to act. We're going to assert. So we need a expected area. So for a 3, 4, 5 triangle, that should be 3 times 4, right? Should be 12. That's the same as the perimeter. How cool is that? What a neat looking triangle. It's 12, sure. And then we'll have we don't really care what the side lengths are at this point here. So let's make the triangle. So we'll say my triangle equals a triangle, given we don't care about the name. And then we'll triangle that set side length of 0 to 3, set side length of 4 and 5, 4 and 5, 2 and 1. And then we'll have the actual area, then, is my triangle.get area. And then we'll assert self.assert equals my expected area and the actual area. Did we get a 12 back out? Uh-oh. Oh, it failed. What's failing here? Build failed. 12 does not equal 6. Uh-oh. Did I mess it up? Oh, no, the square... Semi-perimeter times. I'm sorry?
Did you get one of the semi-perimeter?
I don't know. What did we do wrong here? Semi-perimeter times the semi-perimeter minus, times the semi-perimeter minus, times the semi-perimeter minus. That all looks fine, right? Forcing that one, forcing that one, forcing that one together. Right? Isn't the square root of that? Isn't that right? Okay, so what should it be then? So we should get semi-perimeter is 6 times 6 minus 3 is 3. All right, let's write this down here. So we're going to have square root of 6 times 3 times 2 times 1. Is that right? So 6, 18, 36, square root of 36. It's 6. 1/2 base times height. We forgot the half. Base times height was 12. You guys didn't catch me on that. So 6 is correct. Look at that. 6 was correct. All right. So our test was bad. It should be 6. Give that a run. Hey, our test passes. Well, we remember to take half the base times the height. It works out here. Life is good. Math was correct. We were wrong. Go figure. We okay so far? All right. Lots of fun stuff. And we could make more polygons if we cared to. We don't at this point here. That's fine. We could make specific subtypes of triangle if we wanted to. We could have, these are always right triangles, or these are always going to be isosceles triangles, or I don't know, whatever we wanted to do, we could add that in if we wanted to have that sort of class, right? The world is your oyster. Okay. So we're okay with inheritance. We're okay with testing. All right. I think that's most of what we wanted to cover from the chapter. He's got a fun example with progressions, and we'll practice one of those in the lab, where we actually go and use that to do some stuff from calculus, because one of the entire reasons we do calculus and computer science is sequences and series, which is lots of fun from Calc 2, and I happen to find that interesting. So we'll practice a sequence or a series. I can't remember the difference. One you sum or something like that?
Series is the sum, sequence is just like a sequence.
Thank you. Yep. So yeah, that gets to be fun. We'll see when things converge and test if formulas work and things like that. So it turns out calculators actually use some of that stuff to calculate a bunch of values that are hard to do, which is really neat. So we'll play with some of that. All right, awesome. Yeah.
The inheritance, is it inheriting from the previous formula? When you do triangles, inheriting from.
So it means I get all of the things polygon does. So when we go back and look at our triangle, and you say triangle dot, I get all of these things, and it even tells me, hey, this set side length, get side length, is from the polygon class. This one is from the polygon class. Get areas from the triangle class. Get perimeters from polygon, names from polygon. So it'll show you what comes from what here. So you just get all of those things that class has. Yep.
So if you get it, then what are you going to? Are you still going to put in the values for polygon or the values for triangle?
So if I make an instance of the triangle class, I know it has 3 sides, and then I can go and set my side lengths, 1, 2, and 3, or 0, 1, and 2, right? Because everyone starts counting at 0, like normal people. One of these days it'll catch on, I promise. We'll start teaching kids to start counting at 0. My kids are not having it, but that's okay. Yeah, so it gives you all that behavior, right? Because we are a type of that. And we commit that to GitHub. Should we talk about our first project? Everyone's very excited for Project 0? No? You voting no? We can talk about it Tuesday if you want.
So our second project already started?
No, so we can start it today or we can start it Tuesday if you really want to. We've got time now, but I'm open to either one for you. I probably should commit the stuff from 200, shouldn't I? Do that. Uh, 298. Forgetting to commit a bunch of stuff here. And maybe think of it here with committing. I should probably remember to do that. So, do you want the project now or do you want to wait till Tuesday? I heard one of each side. I need more than that.
It doesn't matter to me.
I'm good with starting.
We're good right now, so.
All right, I think we got more votes for now. Is that okay? All right, we'll talk about it now. So I'm going to go shamelessly copy paste here from last time because that makes my life easier. Which was a copy paste from last time, which is lots of fun. Project 0. All right. So we have the issue with repositories. I wish they would have fixed that, but that's fine. That is okay. Let's go to Project 0. This is projects. We'll have Project 0. Oh, no, goodness. So 2 weeks from today then is going to be the 30th at 2 p.m. Some input tools suck. All right, 2 p.m. I think this is probably about 10 points or so. We'll put a rubric in here in a second. All right, so the URL of your repository or project in that repository, if your project in the repository here, and then we're going to also add a README file with a self-assessment. Have I shown you how to do these with README files? Self-assessment? Okay, cool. Take the screen snip, works out pretty nice. So we're going to make some classes for a pretend game. We're not going to write the user interface. Someone else who knows how to do cool user interfacey things will go do that for us. We're just going to write the classes that hold the information and have all the logic here. Okay? So we're going to have 4 classes. We have units, and essentially when they fight here, if our attack power is greater than or equal to the target's defense, the target dies. So we have some amount of attack, they have some amount of defense. So units have an attack power, which is an integer value. They have a hit points, which is an integer value. Oh, no, shoot, that should be hit points. Hit points. Sorry, if you kill it. Sorry, you got defense in there earlier. Attack power is an int, hit points is an int. They have a given range as an integer value. And then we're imagining this is on some sort of 2D grid somewhere, right? So they've got X and Y position, so they know where they are on the grid here. And they've got a team. So we're going to deal with, there's units together on the same team, units on another team, that sort of thing. And then whether or not they're alive. Because units that are dead don't get to do anything. Their turn gets skipped, essentially. But they're there littering the battlefield, because that makes the game more realistic, right? When dead bodies just disappear, it ruins the immersion of your game. It happens to all of you, right? It's okay. So we're going to have an attack function that accepts a target. So the target will be another unit. Right? So you tell me, here's the other unit I'm attacking. We'll go do the attack thing. If it's within range, right? Again, calculate the distance between 2 points, that triangle theory, and then make sure that it's someone they should attack. So the us team fights anybody on the them team and the chaotic team. The them team fights the us team and the chaotic team, and the chaotic team just shoots at everybody. They don't care. They don't really have a team. They're just insane. So check the teams, make sure that they should fight each other, these sort of things. And then we'll have a move function that moves a given unit wherever it needs to go in the battlefield here. So then our class then, infantry, is going to inherit from unit. It is a type of unit. Right? So we'll have the base class that all of these things share. What's special about this one is its attack power is 5, it has 5 hit points, and then it moves either X or Y no more than 5 units. So you can move along the X-axis or along the Y-axis. We're pretending diagonals don't work. Just sure, it's our game. We're just making it up here. And no more than 5 units. But they could say, hey, I want to move 3 units X plus, or minus 2 X units, whatever that happens to be. So we need to make sure that they can move that range, right, on the X or the Y when we move. And that's the move function. So we're changing the behavior of move specific for infantry. Okay. Then we have artillery. They've got a range of 10 here. Their attack power is 10, but they only have 1 hit point, and they only move 1 at a time. They're very, very slow, right? Then we're going to have cavalry. Cavalry have a range of 5, an attack power of 5. They've got 10 hit points, and they get to move 10 X or Y at a time. So whatever sum of X and Y, as long as it's 10, is okay. Don't bother with the crazy triangle theory, but let them move 10 units some way here. They can make whatever L shape they want to, 3 and then 7, or 6 and then 2. It doesn't have to be up to 10. It doesn't have to be exactly 10, right? They can move pretty quickly along the field here. And then we're going to have a captain class, which is a type of infantry. What's different about the captain is their attack power is 1, but they have 20 hit points. And then what the captain does is, instead of attacking an enemy, it rallies a friendly unit. If they're within range and they're on their team, what it does is restore their hit points magically. It's pretend, right? It's okay. So they rally the unit, get them back up, give them their hit points, and they're back up and running. So they'll be able to move around and go bring their units back up. Right? So that's kind of why it's nice to know if they're dead or not. If you want to make them revive dead units, great. If you want to say, hey, it only works if they have at least 1 hit point, I'm open to that too. Whatever you think makes a more interesting game here. Again, we're just writing the classes for it here. That's all it is. So if we don't have a range, let's assume it's, what should range be? Range should probably be like square root of 2 for the default. So that way, you can get any square around it, including the diagonals. It's probably easiest. Defaults. Do we give a smaller range? We give bigger ranges. I didn't give smaller ranges. Yeah, so that's fine. So we'll assume range then to square root of 2 here for that. We've got hit points for the other classes. Yeah, hit points, hit points, hit points, hit points. Cool. Got attack power, positions, team is alive. Okay. So if you're alive or not is whether or not your hit points is not 0. Right? So our hit points then keep between 0 and max. So when you get revived, you go back up to max for your class. Right? Not everybody goes back up to 20 hit points if you have more than 1 captain, something like that. If you're dead, you're at 0. Is alive is false then. So pretty quick check for that one. So it probably doesn't even need that. Let's just say when attacking, when attacking, reduce the target's hit points by the attacker's attack power. Does that make sense then? So then you'll be dead then if their attack power is more than your hit points, but if not, maybe you just take some damage and you stay up. Does that make sense? Okay. Cool. So that's the one we're working on here. Turn in not a file upload, just the URL, do weeks, and then I got to add the rubric here. So I'll add, this is for project 0, and use this one for grading. This is unit class, and this is infantry class, and this is the cavalry class, artillery class, and then the captain class. Here, those are all 2 each. And tests. So the tests are half the points, right? We add that in here. So you want to test each of your new functions, make sure they do what they're supposed to do, right? In class and tests. Here, there's not going to be a whole lot for some of them, right? And that's okay. Just test what makes them distinct, what makes them unique here. Make sure the values that you're setting for them get set. Right? If you expect a new cavalry to have so many hit points and so much range, make sure you get those back out. So this is not the list of all the functions it should have. This is all the attributes it should have. If we need functions to go get these things and set these things, we got to go add those functions. Right? For those things, you want to make sure they're valid here. Range can't be less than 0. Right? Your attack power can't be less than 0. So let's add some bounds checking to when we set these things. That's implicit to here. This has an attribute. Right, so we have to do a little bit of that thinking, be like, oh, hey, if I'm going to take a value here, what makes it a good value? Right, and add some checking, sanity checking for those sorts of things here. And then test your logic works, right? Make sure you're not attacking the right team, those sort of things is within range. However you want to make your functions for that, it's great. Does that make sense? All right, so that's the 10 points for the first project. We've got 2 weeks to work on it. Again, in 2 weeks, I'll go over the solution first thing in class. Ideally, that's worth your time watching someone else build it, that sort of thing. This will probably take like half an hour because there's 5 different classes, right? We have to write, the unit 1 and then the 4 subclasses, but it goes relatively quick. I've done it before. If it takes you more than half an hour, that's okay. It's supposed to, right? That's sort of the goal here, is it takes you a little bit longer because you're learning it and practicing it, doing those sorts of things. So lab on Tuesday, we'll practice a little progression series, which is lots of fun. We'll play with that one, do a little validation. Should be good. If we had any trouble with the Unix stuff, sorry, I forgot to post. I said I was going to post it, and then I got distracted and didn't post it. And then I remembered like late Tuesday that I said I was going to do it after the lab. So I did post it. If you didn't get it done, that's fine. We'll have lots of time. We can get it done the following Tuesday. It's easier to do on campus because you have to be on our network. There is a VPN you can use, but it's a small pain. The IT services has a support page on how to use the VPN if you like VPNs to not do it from campus, but sure. If you need a little extra time on it, that's fine too. I'm not super concerned. The idea is we're checking our box. And it is cool to go run stuff on someone else's server and offload a bunch of processing work if we have large files, those sorts of things. And I added the note to skip the file transfer bit. But that is the nice thing. You don't want to have to go make the files there. It'd be nice to drag and drop them. That's what the WinSCP tool does for Windows. On Mac, I forget, like FileZilla or something is a pretty common free FTP tool. It just lets you connect and drag and drop files, essentially. So being able to move your file so you don't have to write it in Unix is super nice. But trying to make everyone install that tool to sound like a giant hassle, so I said skip it. I don't know if anyone actually looked at the lab assignment. 5 pieces? Okay. Some people nodded. That's cool. I'm glad you click things.
So you have to be on their UM's
Network.
wireless network to do SSH?
The login server won't respond to anything other than the internal network. Right? So part of the security piece of that is it's just not listening to the public internet. Like, nope, so you have to get on our network, then you can talk to it. So it's just a way of securing it a little bit, which is fun. Yeah.
Glad you're interested.
You can use the VPN like if you are talking.
Yeah, so the VPN should work. IT supports it. I have nothing to do with the VPN, so again, I don't recommend it. But if you want to play with it, have fun, go for it. It might be fun to install and try, but it's just one more headache for me I'd like to avoid. All right, we good then? Awesome. Happy Thursday. Good to see you all. Sorry I missed you Tuesday. I'll see you back for lab on Tuesday.